The stripped exterior thermoplastic wrap around the conductors raises concerns. This wrap provides insulation and protection against moisture and abrasion. If it is removed, the integrity of the conductors could be compromised, which increases the risk of electrical shock and fire. The recommendation is to rewrap the conductors using a suitable electrical tape to provide insulation and protection. There are different types of electrical tape available, each designed for specific applications. Firstly, general-purpose vinyl electrical tape is suitable for most low-voltage applications. It provides good insulation and protection against moisture. Secondly, high-temperature electrical tape is designed for use in areas where temperatures may exceed the limits of general-purpose tape. Thirdly, self-fusing silicone rubber tape creates a waterproof and airtight seal, ideal for protecting splices in damp or corrosive environment. When rewrapping the conductors, ensure the surface is clean and dry. Overlap each layer of tape by at least 50% to create a secure and watertight seal. Stretch the tape slightly as you wrap it to conform to the shape of the conductors and create a tight bond. Multiple layers of tape can be applied for added protection and insulation. The breach in the masonry block penetration also causes concern. Masonry block penetration is designed to provide a fire-rated barrier between the exterior and interior of the building. Breaching the barrier could allow fire or smoke to spread into the dwelling in the event of a fire. It is recommended to seal the breach with a suitable fire-rated sealant to restore the fire rating of the penetration. Fire-rated sealants are specifically formulated to resist the passage of fire and smoke for a specified period of time. Firstly, intumescent sealants expand when exposed to high temperatures, filling gaps and preventing the spread of fire. Secondly, fire-resistant silicone sealants provide a flexible and durable seal that can withstand high temperatures. Thirdly, fire-rated caulk is a cost-effective option for sealing small gaps and cracks. Before applying fire-rated sealant, clean the surface of any debris or loose material. Apply the sealant according to the manufacturer's instructions, ensuring that it completely fills the breach. Smooth the sealant with a trowel or potty knife to create a neat and professional finish. Allow the sealant to fully cure before exposing it to fire or smoke. While the splice itself appears to be properly made and secure, and the conduit used for the splice seems to be adequately supported, it is still highly recommended to contact a qualified electrician to inspect the splice and verify its safety. A qualified electrician can assess the overall condition of the electrical system and identify any potential hazards. They can also perform tests to ensure that the splice is properly made and that the conductors are adequately insulated. The electrician can also inspect the conduit support to ensure that it is properly installed and that it is not damaged. The NEC, or National Electrical Code, provides guidelines for electrical installations and safety. Firstly, NEC Section 110.12 covers mechanical execution of work, requiring installations to be neat and workmanlike. Secondly, NEC Section 300.4 addresses protection against physical damage, requiring conductors to be protected from abrasion. Thirdly, NEC Section 314.40 covers the proper use of outlet boxes and fittings, ensuring that conductors are properly supported and protected. Fourthly, NEC Section 330.30 details securing and supporting requirements for Type MC cable. Fifthly, NEC Section 725.8 addresses the separation of Class 1, Class 2, and Class 3 circuits. It's important to note that electrical work should only be performed by qualified individuals who are familiar with the NEC and local electrical codes. Improperly installed electrical systems can pose a serious risk of fire, electrical shock, and injury. If unsure about any aspect of electrical work, always consult a qualified electrician. The importance of proper grounding and bonding in electrical systems cannot be overstated. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Firstly, NEC Section 250 covers grounding and bonding requirements, specifying the size and type of grounding conductors. Secondly, NEC Section 250.104 addresses bonding of metal water piping systems and other metal objects. Thirdly, NEC Section 250.118 lists acceptable grounding conductors. It is recommended to use a ground fault circuit interrupter, or GFCI, in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. A GFCI monitors the current flowing through a circuit and quickly shuts off the power if it detects a ground fault. Firstly, NEC Section 210.8 requires GFCI protection for receptacles in certain locations. Secondly, a GFCI outlet or circuit breaker can be installed to provide GFCI protection. Regular testing of GFCI devices is essential to ensure that they are functioning properly. Press the test button on the GFCI device. The reset button should pop out indicating that the device has tripped. Press the reset button to restore power to the circuit. If the GFCI device does not trip when the test button is pressed, it should be replaced immediately. Surge protection devices, or SPDs, protect electrical equipment from voltage spikes caused by lightning strikes or power surges. SPD divert excess voltage away from sensitive electronic components, preventing damage. Firstly, NEC Section 230.67 requires surge protection for dwelling units. Secondly, SPD can be installed at the service entrance or at individual branch circuits. Thirdly, choose an SPD with a high surge current rating to provide adequate protection. Regular maintenance of electrical systems is essential to ensure their safety and reliability. Schedule a qualified electrician to inspect the electrical system regularly, especially in older homes. Replace any damaged or worn wiring, outlets, and switches. Keep electrical panels clean and free of obstructions. Test smoke detectors and carbon monoxide detectors regularly. The proper use of extension cords and power strips is important to prevent overloading circuits. Use extension cords only temporarily and avoid running them under carpets or furniture. Use power strips with built-in circuit breakers to protect against overloads. Never plug one extension cord into another. The safe use of electrical appliances is important to prevent electrical shock and fire. Read and follow the manufacturer's instructions for all electrical appliances. Do not use appliances with frayed cords or damaged plugs. Never immerse electrical appliances in water. Unplug appliances when not in use. The importance of arc fault circuit interrupters, or size, in preventing electrical fires cannot be overstated. A size detects arc faults, which are dangerous electrical conditions that can cause fires. Firstly, NEC Section 210.12 requires FSI protection for branch circuits in dwelling units. Secondly, FSIs can be installed in place of standard circuit breakers. Thirdly, regular testing of FSI devices is essential to ensure that they are functioning properly. When working with electricity, always follow these safety precautions. Turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools to prevent electrical shock. Wear rubber gloves and eye protection. Never work on electrical circuits when wet or damp. If unsure about any aspect of electrical work, always consult a qualified electrician. Electrical safety is everyone's responsibility. By following these recommendations and taking appropriate precautions, one can help prevent electrical accidents and ensure the safety of the dwelling and its occupants. Remember to always consult with qualified professionals for any electrical work to ensure compliance with local codes and safety standards. Prioritize safety to protect oneself and others from potential hazards associated with electricity.